We are going to talk about section 6.4.2, work, pumping liquid from a tank. So some crocks are used in basements to help prevent flooding, and you can see my picture of it, and our goal is to figure out how much work does this sump crock actually accomplish. And so we are going to think about this. If you imagine if you kept going all the way, this would actually be a cone. So this is just a frustum of a cone. And what's going to happen is you're going to pump water out vertically upwards to a drain that is located at ground level just outside the basement window. And to accomplish this, the pump must send the water to a location 9 feet above the surface. So you're actually going to go an additional 9 feet, which is important to keep in mind as we're working. And so when we're doing this, it turns out it's most think of the positive x-axis going down and the positive y-axis going right. So we will. And what we know about this particular one is that it's 3 feet in diameter across this way. And since we've chosen the center, that means it's at 0.0, 1.5. And then we also know how tall it is, which is 4 feet. And then we also know that it's got a diameter of 1.5 feet on the bottom. So we know that this point, right, came down 4, which is like up 4 if you think about it, like in the positive x direction, and then over half of 1.5, which is 0.75. And what we're ultimately going to do is try and come up with work. So first, you want to notice that as you do this, you're actually removing a slice of it that looks just like what? That's right, a cylinder. And so we need pi r squared, if you're thinking about that, times this delta x, because it'll change at x. Okay, and if I want r, then what I really need is I need to know the equation of this line. Alright, and I've got 2 points. So, since it's linear, I'm just going to do y equals the change in y. So I've got 1.5 minus 0.75 over 0 minus 4. And that's my slope times x plus, alright, and my y value is 1.5 when x is 0. So I can just add that in for my y-intercept. And then I simplify this and I get y equals negative 3 over 16x plus 1.5. And so all we need to do now is work through this. And so whenever you're trying to find work, we start by finding the volume of a slice. And in our case, remember, it is a cylinder, okay? So the area is a circle, pi times the radius. Alright, and we found that the radius, so at any x value, this is going to be my height. So I get negative 3 over 16x plus 1.5, and we're going to square that. And then, and so that gives me feet squared, I should point out. And we're going to multiply by delta x, which gives me another feet. So altogether, my units are feet cubed. So then I need to find the force it takes, or the weight, and so we're going to do, we know that water weighs, because that's what's filled in the sump, right? Because if you're trying to prevent flooding, you've got water in there. And so we need to do 62.4 pounds per feet cubed times pi times negative 3 over 16x plus 1.5 squared delta x feet cubed, and feet cubed over feet cubed cancels, so I'm just left with pounds overall for my units here. And before we can do work, we need to think about what distance is it going. Well, wherever I'm at, this is a distance of x, but then I go an additional 9 feet, so overall the distance a slice goes is x plus 9 feet. Alright. So then now we want the work of a slice, so we do the force of the slice times the distance of the slice. And so that gives me all together if I write really small, 62.4 pi times negative 3 over 16x plus 1.5 squared delta x times parentheses x plus 9, and then remember this was pound and this is foot, so I get that foot-pound as my units. So then if I want the work, I want you to think about this. Now we're emptying all of it out, and so we start at x equals 0 and we go all the way to x equals 4. So my work is going to integrate from 0 to 4. And then I'm going to put my W slice in here, so I get 62.4 pi times negative 3 over 16x plus 1.5, that radius is squared, times x plus 9, and then I'm going to integrate with respect to x, so that comes last. And notice I haven't changed the units, so it's still in foot-pounds. And so then if I want to find the work, all I do to completely empty my sump tank, I would find this integral, which you could actually multiply out and get, or you could use Wolfram Alpha, and so, or I think you might even be able to use Desmos, but anyway you do it, you get 10,970.5 pi foot-pounds. And it's that easy. So what do we have to watch out for? Well, what happens if we are in metric? Alright, so we're going to watch out for metric. So if something's given to us in metric units rather than in weight, then you're going to have to think about how the force is equal to mass times acceleration. And remember, acceleration is my gravitational constant, 9.81 newtons per kilogram. So you actually get an extra step. So there's an extra step. Alright, and you're going to practice with this next time.